Welcome back. Thank you. Okay. Now, what I want to look at now is called earthing and bonding. Now, it is very important that you are compliant with the IEE regulations in regards to earthing and bonding, because what I'm going to show you now was the specifications and the regulations as it was then. But you need to be sure that you're compliant with the current regulations as they are now. Okay, 2024. And this is important. Okay, so bear in mind what I'm going to show you now and take in account to be compliant with current regulations as they are now. But what I'm showing you is a good starting point for you to have a practice on and to keep in mind. And if you keep the practice in mind, you cannot go wrong. The changes may come along, but you will always be up to date with it in that sense that you won't be behind or endangering anybody else. Now, please remember that health and safety takes priority. The IE regulations is statutory, well, they are a requirement in regards to the electrical installation for us to be compliant with at any point in time or any electrical work that we are undertaking. Okay, right. Let me just go and start my work and thank you for listening. Right, again, we're looking at sitting gills. Let me get started. I've always got to, but never mind. I prefer this. Okay, okay, do one here, and one here, and do we, okay, that's what we got here. Okay, it's funny, this, okay, uh, okay, okay, I think about, yes, okay, right, sitting gills, and we are looking at earthing and bonding one, okay? Right, earthing and bonding one. I repeat, earthing and bonding one. And we are in session 4, okay? But never mind that. Earthing and bonding one is will be your main element in regards to the video feedback. Aims and objectives of this session, to be able to differentiate between the terms earthing and bonding, to be able to give example of each, okay? Here's the previous work for purely for revisional purposes. Okay. What is Earth? The whole of the world may be considered as a vast conductor which is at reference zero potential. Potential here being the difference between two voltages. People are usually more or less in contact with Earth. So if other parts which are open to touch become charged at a different voltage, right, let me just recap that. Okay. Sitting gills, okay, and we're looking at earthing and bonding session 4, but never mind the session 4, earthing and bonding. or the aims and object. Sorry, just take it out. The aims and objectives of this session to be able to differentiate between the terms earthing and bonding, to be able to give example of each. That's the revisionary bit, okay? That's the work we have done previously, okay? Now, as said before, what is Earth? The whole of the world may be considered as a vast conductor, which is at reference zero potential. Potential here being the difference between two voltages. People are usually more or less in contact with Earth. So if other parts which are open to touch become charged at a different voltage from Earth, a shock hazard exists. Some types of soil make a poor Earth. Symbol for Earth is here. Okay. Now, potential differences. When we have a voltage of potential difference of 230 volts, we have raised the voltage to 230 volts above zero. And this is just giving you an illustration of the voltages above zero. Okay? Voltages can be also raised above another voltage, so it is important to always know the strength, the starting reference point. It's me. Okay. Didn't background damage, didn't I? Nope. Right, it's okay. I'm just looking at something here at the moment. Hang on. Bear with me. Let me just make sure I'm on the right one. Yes. Reference point. Now this is your delta connection. You'll find that there's no star point on your delta part of the transformer. But star connection, you have a center point. You have a tapping that brings you down to earth. Okay, so you can take off various voltages in the star connection than you can in the delta. Delta allows you to have a great deal of current there, thereby allowing your transformer on the star side to be able to have power to draw on. The star point of the supply authority's transformer on the secondary side is connected to earth, which is accepted as being 0 volts. The primary of the supply authority's transformer HV has an earth provided, and this is connected to the structure of the transformer. Okay? Now, earth fault loop path. Now, again, make sure that you're compliant with the IEE regulations in regards to earth loop fault. Okay? Earth fault loop path. Okay? That you are up to date with the current issues, whether the 18th or the 19th edition of the IE regs. Now, I'm familiar with 17th edition, and I know that there have been some changes or amendments to certain things. Okay? But it is your responsibility to make sure and to check. Earth fault loop path. The earth loop is the path which begins at a fault, passes through the earth conductor, then into the submains, and then back to the point of the fault. It should have a low value of impedance. Okay, and this is what your earth part fault would look like. Okay, fault occurred. Okay, go through the looping. Now fuse, because you have a fault, it should draw a large load, current load to appear across the fuse. We should blow the fuse to protect the cable. Okay, and that is essential. But we use circuit breakers now, which is quicker and more effective, and we also use RCDs. The problem for me with an RCD, and I'll be honest with you, is that although it is efficient and effective, the circuit breakers is not operating before the RCD operates. So you have a board, maybe a 5 or 6 circuit breakers, then controlled by an RCD. Now the RCD trips before the circuit breakers does. I have no idea what that's about, but that's what I've noticed. Now whether that's good or not, I don't know. Um, I would have thought that the circuit breaker should have operated before the RCD. I know the RCD is residual current device and it's there to pick that up, but should the RCD be tripping out, thereby tripping out all those 5 circuits on the board? That's my little bugbear. But I noticed it the other day when I went somewhere or the other. I was not happy about that, but we'll see how it goes. But the main thing is that it did protect the circuits and it did protect the fault. What happened was that someone plugged in a kettle, and the kettle must have been 50 years old, and the cabling had gone down to ground, and he had tripped the circuit breakers. There were 5 circuits on this fuse board. I mean, there's 12 altogether, but this particular RCD controls 5, and those 5 circuits, none of the circuit breakers tripped out, but the RCD did trip out. But I can suppose you can say that it's there, it's actually done its job, which I would agree with. The main thing was it was quite safe. Okay, let's get back to work. I'm like digressing at the moment. Again, your earth fault loop impedance should have a, a low value of impedance. Okay. Reason for providing earth and bonding in an installation: sufficient current should flow under an earth fault so that the protected device, fuse or a circuit breaker, operates within a predefined time. While the fault exists, metal work could rise to a high potential. Bonding occurs to enable exposed and extraneous metalwork to be linked together. This gives us an equipotential zone. Now, you need to review that in the sense that that may have changed somewhat, equipotential bonding as I knew it then, but be aware of that. So check the IE regulations to be sure that you're compliant with the current regs, okay, in regard to equipotential bonding. That is important that you understand that. Exposed conductive parts. An exposed conductive part is a conductive part of equipment which can be touched and which is not a live part but may become live under fault conditions. If it is not part of a fault current circuit, then it is not an exposed conductive part. Just because something is metal doesn't make it mean that it necessarily needs bonding. But exposed conductive parts, metal casing of the cooker is exposed conductive parts. You're trunking in an exposed conductive part, and when you're running trunking, you'll normally bond it down to earth anyway. Okay, you will shine off the paint off it, then rub it down, and then you put a pin into it and bond it down to earth. Normally with 2.5 cable size. Okay. But again, you must comply with the IE regulations. Check, 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 and double check the regulations. Right, extraneous conductive part, and again, a conductive part liable to produce a potential generally an earth potential and not forming part of the electrical insulation. Your gas meter, for instance. Okay, that is normal. That needs to be bonded. Your water pipe. Okay, if any metal comes out of the ground and we can assume the ground is at earth potential, then that metal work is an extraneous conductive part and will need to be bonded. Yes, me, I'm getting kind of hungry lunch now. Okay, circuit protective conductors, your CPC. Now, where you need to use an earth electrode, mainly on farming sites, TT systems, I believe, okay? Be sure that your earthing is effective and you have as low resistance as possible flowing to earth, okay? That if a fault occurs, that the resistance going to ground is as low as possible so that it operates your protective devices. You do not want circuit going down to earth and leaking current but has not tripped the device. That will cause you problems and you may need a new installation because your cable could well be damaged, okay? BS 7671 defines the CPC as a protective conductor connecting conductive parts of equipment to the main earthing terminal, okay? Circuit protective conductors, a single core cable, a conductor in a cable, an insulated or bare conductor, a fixed bare or insulated conductor, a metal covering such as the mount armoring of cable, that can also be a conductive part, a metal conduit or other enclosures, an extraneous conductive part whose continuity can be guaranteed, whose cross-sectional area is sufficient, which cannot be removed and has been adapted to its new use if necessary. Okay. Now again, read this for yourself. You don't need me to actually read this out for you. But now let me look at this protective. Let me see if I can find anything on my screen for a moment. And that 1 second, bear with me for a second. Let me just try. Okay, all right. Oh, okay. Thank you for listening. I hope you found this useful. Let me just see what I can, if I, bear with me for a second. Let me just see if I can run something here. 1 second, bear with me for a second. If I can get anything on this. I should have brought this up before, shouldn't I? Okay. No, I'm going to have to leave that for now. But thank you anyway. Have a good day. Bye bye. Thank you.